This conference will now be recorded.
Hello, good morning, everyone.
Good morning.
Hope, yeah, Ajay, good morning. Hope my voice is audible to Sima Shravan Kumar.
Yes, Madan.
Yeah,
You are audible, Madan.
yeah. So, in the first demo, we discussed on DevOps, right? So we discussed various things, various tools. So you have listened it from the beginning. If you have not listened it from the beginning, if you joined on the day in between, then I like to take it again, if you wish. If anybody joined in between and not listened from the beginning, then I will take it again if you want. Who has just now joined? What's your good name, please? Hi, good morning, Revanti. Good morning. So, Sima, Shravan Kumar, Ajay, the first, yeah,
Morning,
Revanti.
Madan.
Hi, Revanti. Good morning. Is it this first class, Revanti, for you?
Yes, Madan.
Okay. Right. Is that fine, Ajay, Sima, Shravan Kumar? If I take DevOps introduction once more, with introduction of all the tools.
Okay, Madan.
Oh,
It's
yes, sir.
fine for me.
I'm sorry, I didn't get you. Can you ping me if your voice is somewhat? If yes, type here, please. Okay. So we will wait for a few more minutes, please, so that others will join, and then we'll continue immediately. Ajay, what do you say? Ajay and Seven Kumar. I think Seven Kumar, you joined in between. It seems right, the first demo on DevOps. Saravanan, I like to talk to you actually. Can you please talk? Can you introduce yourself? I maybe introduced already. Maybe I forgot about your background, please. Okay. So before I start introduction to DevOps, I like to inform you that we will be conducting classes on weekends as well, whenever required. After one week before, I will inform you so that you can also plan well. Uh, Accordingly, we will spend some time on weekends as well, so that we can cover more topics. More topics. So if possible, I can add some more topics which are not in the curriculum in the course. That also will cover if time permits. If we able to complete some sessions on weekends as well, then that allows me to take some more sessions if required. Okay, that is about it. Sure, Simma. So the only problem is no, you people have to practice. That is the only thing challenging for you. From my side, I am fine to teach you more topics, but the only thing is after having the class, I will share the recordings so that you can start practicing immediately. So bear with me for 1 or 2 days like this, so that once course starts, then you won't get this much time. So Revanti and who have not listened on the day the beginning, then for them I am taking a repeated clip session. Yes, yes, thanks you. So okay, let's start the class now. Uh, Hello, good morning, Redepa. You just joined, right? Hi, Maidar.
Yeah, good morning. Yeah.
Hi. Redepa, can you please introduce yourself, please? I just want to know your background, education background, and if you're working, so what area you're working on? I want to know. Uh, One moment, please.
Yeah, hi. Myself, Redem Pavai. I'm working as a right now DevOps engineer only, but in the support I'm getting actually. I want to upgrade myself in Docker and Kubernetes and end to end with the cloud. That's why I'm looking
Okay.
at.
So, how much experience you have, Redepa, on that?
Total 5 years I have. In the first I worked on is like a testing field. I worked on 1 year, 1.5 year. Then I moved AWS DevOps. I have moved like a
Got it.
Jenkins. I worked on in AWS and support like database SQL and everything like that.
Got it. Got it. Thank you. Thank you, Redepa. And Revanti, your background, please. Your education. I forgot your background, please. I didn't able to hear you. Maybe you informed me. Just is your computer science background, Revanti? You are on mute, Revanti. Are you speaking?
Hello? Yes, Madan.
Yeah. Sorry. So I was asking, is your background computer science background?
Computer science. No, no, no. Actually, my background is electrical, triple E,
Okay. Right. Right. So when you passed out?
2019.
Okay. Got it. Got it. Got it. Thanks, Revanti. Okay. Right. So as I told you, let's begin. So as I told you, no, some 20 years back. So 20 years back, there are mostly desktop applications. Desktop applications used to be there. Desktop applications example are like your MS Word is a desktop application, right? MS Word, your calculator, right? And your MS Paint. These are all desktop applications, right? So these are not these are not web applications. At that time, uh, one moment, please. Let me share my screen completely. Yep. So at the time, there was no such, web applications. There are very few web applications, very few. So there are no e-commerce web applications at that time. There are no e-commerce. There are no web apps at that time. So slowly, as we are seeing now, we have got lot of e-commerce applications like Amazon.in and right, and what do you call Flipkart, many more are there, right, in the market. So at the time, when you talking about 20-25 years back, what happened, right? uh, as you know, the administrators used to handle all the tasks. They used to take all the handle all the tasks, like preparing from networking to, right, networking to installing softwares, everything they will used to do. And these people used to uh, serve to multiple projects. They used to serve multiple projects actually. So suppose, assume, if you take Infosys will have multiple products, right? So assume there are a lot of applications. Then these administrators used to take uh, all the pain actually. They have to create the infrastructure and install the applications for more than 3-4 applications. Some group of administrators used to handle more than 3 to 4 applications at that time. But as you know, at the time the projects used to take long time. That means the project one project once the project as it came. So initially, once a client gives a project to them, so initially they what they used to do, they used to do requirements gathering. They gather the requirements initially, right? And once the requirements are gathering, they who has to gather this? The project teams used to gather the requirements, not the administration's part is only networking and preparing the infrastructure and installing the softwares. That is only their job. But what I'm trying to say here is that completely administrators used to take care everything from networking to preparing the infrastructure to say deploying the applications. Everything they used to take care. So that is, I'm talking about 20-25 years back actually. So at the time, the development team is to gather the requirements, and they have to analyze the analysis on those requirements whatever they gathered. And then they finally, the architects of that project used to design the project, right? Once they design the project, in the designing itself, they used to choose the which language to be used to develop the application. And then once it is confirmed, then they give it to coding developers for coding. And then it goes to testing, for testing. So up to here, no problem. But after that, administrators come into picture. What they do, they will do the deployment. They will do the deployment, and what they do, after deploying the application, they have to monitor the application. So monitoring has to be done. These two parts taken care of by the administrators. That's right. So now, at the time, because they are developing mostly on desktop applications, that the coding team used to take a lot of time actually. A lot of time means, for example, they used to take 6 months to, it varies actually, 6 months to 2 years. They develop the code, and only after that they will give it for coding. Sorry, testing. Only after that, after development, they will give it for testing, right? But here problem is that the end user, the client, will able to see the output of that uh, coding only after 6 months or 2 years, because the applications are like that. The desktop application development used to take like that. So at that time they use a lot of legacy applications like VC++, right? They used to now very less projects are there on VC++, right? So at the time they used to develop using language called VC++, right? Com, right? Many are there. ATL. At the time there is even not no .NET. At the time, not at there. So at the time, VC++, these applications they used to develop the applications, desktop applications, right? At the time, it is fine for them. The clients also fine with working on with waiting for this much period, because these are desktop applications used to take that much time actually. But now when the competition begin, now from past 15 16 years, so e-commerce started, right? Then e-commerce started. Now in e-commerce, for example, if you take Amazon.in, they cannot wait for this many months and years, right? They cannot wait. So what they did is, they want some part of the project should be developed initially, so that they can use that partial project developed by the developers. They can start business with that partial development. That means, if the developers developed, assume some 10, suppose in Amazon.com.in we have lot of products, right? So out of those lot of products, now e-commerce is now in very competition, then the client used to say that do not develop complete whole web application, develop only initial some major pages, major web pages, like login page. Okay, once log in the main page, so these pages, these are called all pages are called features. They are called features. So they will say that in initially do not spend this much time, spend we want some features, some key features, like no, we want to a product called mobile page, I want a complete feature on mobile, a feature need to be completed. Like that they will tell to the company, the development the Wipro company and Infosys company, saying that initially we want some 10 products to be released, some 10 products, or you can say 10 really features, you can say. So initially release these 10 products for us, so that we can immediately deploy into the market, so that the customers can start logging into our web application amazon.in, and they can at least buy these 10 products, and after some time release another 10 products. That way we our product, our website will continue growing. That way they are doing now. Initially they started that way only, now they have full-fledged applications now on their web page, on their website. Okay, so fine, that is about it. So now what happened is that, so previously this is called, this comes under this requirement gathering, everything comes under we are, if you are in development, this comes under software development life cycle. This comes under the software development life cycle. So is a part, these are all the different steps in the software development life cycle. In this software development cycle, at the time 20 years back, they followed a methodology called waterfall methodology. So in waterfall methodology, these all things are continued for a long time. Decades together, this waterfall methodology was successful at that time. But the same waterfall methodology will not work when you come to web applications, like e-commerce web applications, will not work. That is the reason a new methodology arrived. A new methodology called agile methodology. In this agile methodology, one moment please, am I able to share my screen? Yes, yes, fine. Yeah, in this agile methodology, there are some new terminology introduced, like no sprint, features, stories, right? Many more are there. Many more are there, right? What do you call sprint planning? Many terminologies arrived. I will discuss these things in future also. Now I will just give you an overview on this. Sprint means nothing but timeline. Timeline. So timeline nothing means how many days. So each sprint contains how many days. It differs company to company. Normally they follow 10 days or 2 weeks, including weekends. 2 weeks is a sprint plan. So in one sprint they have to complete one feature. In one sprint, that is in 2 weeks, they have to finish. They have to complete one feature. So the company wants 10 features, for example. The company wants 10 features to be released in next coming 2 weeks. In 2 weeks, they want 10 features to be released, so that the application will be available to the end users. So the one sprint in 15 days they cannot come, in 2 weeks they cannot complete all the 10 features, right? That is the reason in real time what happens is, there will be around, as per the number of features, they will have number of teams. Normally they will have 10 teams, some 10 teams or 15 teams, as per the how many products, how many features they have to release. As per that they will design the team size, and after team is prepared, and each team will contain around, each team will have around 6 developers, right? And two testing people, two testers will be there, right? And one lead will be there, and one scrum master will be there for every team. So what they do, we will talk one time sometime later, but just we will give importance to only 6 developers now. So these 6 developers, 10 teams, 160 developers, right? 60 developers will start development. So these 10 teams, in after completing one sprint completed, then each team will release one feature. They will, in each team So each sprint, because 10 teams are there, okay, after each sprint, right, after each sprint, then 10 features will be released, right? So that will, that this way it goes on, that way it goes on. You are new to today, you can ask me if you have any questions till now. You are new today, you can ask if you have any questions. And actually this is for some of them it is repeating class, I understand, sorry for that, but you are attended in between on that day, it will helpful for you. Okay. So now problem is that, okay, that is fine, developers able to finish their features in 10 15 in 2 weeks, and testing team also able to test it in in that 2 week in that 2 weeks period only. Then what the real problem here is that the real problem is with the deployment and monitoring part. So this deployment and monitoring has to be done by the administrators, right? So previously when they are following waterfall methodology, they could have they are happily able to finish the task deployment and monitoring, and they used to handle multiple projects at that time, because each project used to take long time, right? That is the reason they are able to deploy the and monitor the multiple projects effortlessly. But because in agile methodology, every 2 weeks in every 2 weeks the feature has to be completed, because of that challenge. So what happened is now the problem arises with deploying process. They cannot cope up to deploy the applications in every 15 days, they cannot do it, because they also handle multiple projects. So that is the reason what happened is the software industry found, understood the situation, and what they did is they created some softwares and released into the market. They created some softwares called automated softwares. These automated softwares we can also call automated tools. So these tools are released into the market only to help the administrators, so that if these administrators able to use those tools, automated tools, then they can easily deploy these softwares. Once the developers finish in 2 weeks, then they can immediately deploy them using the tools. So these tools, many tools are released in the market, and many sustained and many not did not sustain. So what in our course, the tools which we are learning, so those are very much sustained and very much mature tools. So in the industry using them, most of the industries using those tools. So those tools we are going to learn, right? So because these administrators now learn those tools now, and they are now called as DevOps engineers. We call them as DevOps engineers. So then in that scenario, then did administrators gone? Then no, still administrators are there. Still administrators are there, but they want to do the full-fledged. They will not involve in the agile methodology. They will not involve in this agile methodology. Only DevOps engineers will involve in this agile methodology. They will sit the DevOps engineers sit with the team, the developers team. They sit together with the same floor. They work they work with collaboratively. Whereas administrators, they will take only responsibility of infrastructure in the on a data center of the Infosys company or any company. So now not only administrators learned the these new automated tools, many are started, even developers also started learning DevOps tools. So testing team also converted from their role to DevOps role. So such is the demand for DevOps engineering role in the market now. Why so? We'll come to know slowly. So without spending much time, uh, let me understand this part. So as I told you, in the waterfall, the coding part itself takes long time, and testing happens after 1 year period or 2 years period, and then deployment will be done. And agile design code is happening, but there is no deployment happening, right? So now agile will not work alone. Agile will not work alone. So agile with continuous deployment, if it is the if it is possible, then it will be good for the industry, right? So design, code, test, deployment also happens in the same sprint, in this 2 week sprint. And again, design, code, test and deployment, if it happens in the same sprint, then for that to happen, that continuous deployment requires DevOps. Hopefully you should by now you might have understood why DevOps is. So to overcome the drawbacks of traditional software development lifecycle models, that is waterfall methodology, and we require for collaboration between development and operations team, and automate the complete overflow. So the developers and operations team, they work together. Developers, these people will develop the code and create the applications. Operations team, these people will prepare the infrastructure and maintain the infrastructure. And DevOps engineers come into picture to perform all the automation activities and deployments. That I will explain in a moment. See, for example, you got a Java project, then administrator will do what? They will set up the server setup for local machines, development environment, SIT environment, UAT environment, pre-prod production environment. So here UAT in this picture I am not mentioned. So it may be there, or directly pre-production will be there. So UAT means user acceptance testing, and SIT means system integration testing. And developers is a development team. Development environment is a environment where on the local machines, on the left side you see I'm showing 3 machines here. So on these 3 machines, in real time, these three are working, 3 developers. In the real time there won't be 3 developers. In real time there will be more than 50 developers working on the same project, 50 developers. So when these 50 developers work on their project, so they will work individually on their local machine, on the local laptop, on the desktop they will work, and they will test whether the application working or not. So every developer work on his local machine, and they will test whether their application working or not. If everybody's code is working, then what they do, they have to move all their code to development server. On the development server also, when their code are merged together, there also all their whatever they worked on the features, all features should work properly even after merging their code together on the development environment. So they have to move finally to the development environment, and everybody has to test the application which is on the development environment. So every, because if somebody wrote some code and other person wrote some code, because of his code may, others code may be have some problem. That is the reason what they do, they combine their code and deploy on the development server. Who are non-IT, they don't hesitate. You can ask me, interrupt me, no problem in between if you are not understanding any of the keyword here. I'm trying to explain in a very layman way. So I'm trying my best to not to use technical words here. So these developers do the development code, and finally they have to deploy into development server. And after deploying to development server, they have to verify that whether his code is working properly or not, or it may be affected because of other person's code. They have to cross check among them. They have to cross check. If it is not working, they have to fix them, and again they have to deploy into the development environment again. So till that works perfectly, then only it has to move to another environment called SIT environment, or system integration testing environment, where the testing team will test the application. Here the developers will not come into picture. They will not connect to this server. They are not allowed to do that. Only testing team will connect to the server, and they will test all the features. For example, developers created 10 features. They have completed 10 features. Then the testing team will test all the 10 features working or not properly, and then it will be moved to, if it is working fine, no problem. Otherwise they will request to developers saying that your code is not working. They will ask to fix it. Once they fix it, again the development team will move it to development servers. Again they will test again finally they will move it to SIT. So it takes this all rotates actually. After that, if everything working fine, then it will be moved to pre-production servers. So pre-production servers are the servers where are pre-production. It can be pre-production. In some companies they won't use pre-production, they will use UAT environment. UAT means user acceptance testing environment, where some one person from the company, from the Amazon, for example, if you take Amazon, so from person from Amazon itself, they log into this server, and they will test whether the features are working as expected or not. If they are working fine, then they will approve it. Once they are approved it, then the application will be moved to production server or live server, so that everybody can access. So Everybody, you and me, can log into the amazon.in and then we can purchase those products online. So here you see in this picture, I told you different environments here, right? Dev environment, SIT, pre-prod. So these environments in this picture, this is one server I'm showing here instead of all those environments. This environment can be dev environment, this can be SIT, this can be pre-prod, this can be production. But in between, I have introduced these three tools now. These are three tools. Just now I'm introducing you now. These are the DevOps tools, automation tools, I can say. So one is GitHub, another is Jenkins, another is Maven. Only three I have introduced. Many more are there, but as of now, let's deal with these three now. So when these 50 developers develop their code, actually they move their code to a GitHub repository. GitHub repository is a repository which will able to store all the code which the developers have developed and pushed into this repository. This GitHub have the code actually. The code can be Java code, it can be .NET code, it can be Angular or React or Python. It can store any code, right? So and GitHub also do what? It also maintains version. It's a called as a version control system as well. Version control system. Why it is called version control system? Version control system means out of 50 developers, because these 50 developers working, they will not work for only 1 week, right? 2 weeks they won't work, right? They will work for 2 years or 3 years. The project will continue for 3 years, 4 years also. So again in this 2 3 years period, every 15 days they will release features, right? So in this two years period, so suppose I want to know on so and so day who did those changes, some code changes, who did those things. So those history we can get it from GitHub. The GitHub is a tool which manages all the history about the development, who did what changes, everything we can extract those details. That helps to the team a lot actually. Suppose assume we release the project and the project is not working, but the previous release was working fine. Then no, we can release the previous version by getting the previous version from the GitHub. How to do that we will see later on practically, but as of now try to understand GitHub to do two jobs. One is it stores the code as well as it maintains the version control system. And GitHub and Jenkins is called as a mediator tool. It's a mediator tool. Mediator means, by now you should understand, it's a mediator. It communicates with multiple tools. It communicates with all the tools which we are going to learn in this course. So Jenkins is called mediator tool, or we also call it as a CI/CD tool, continuous integration, continuous deployment tool. We can call that as well. So this Jenkins will do what? So once GitHub got the latest code, GitHub will immediately informs to Jenkins saying that I have received latest code. Then Jenkins will immediately pull the latest code from GitHub and it will move that code to Maven tool. Maven tool is called, this tool is nothing but a build tool. The build tool do what? It will convert that Java code, or here Maven deals only with Java code. So it converts the Java code to binary file. Why it has to do that? Because the computer will not understand Java, right? It won't understand Java, right? That is the reason the Maven build tool do what? It will convert in such a way that the computer can understand, the machine can understand it. So it converts the binary file. Binary file means nothing but zeros and ones, right? So once the Maven converted the Java code to binary file, then Maven will inform to Jenkins saying that the binary file is ready. Then Jenkins will pull the binary file and installs that application onto the target machine. The target machine here, it can be dev server or SIT or could be pre-prod or production server. When Jenkins assume this is dev server, then Jenkins, once it install the application into the dev server, then Jenkins also emails to every developer, everyone in the team, even the manager, everyone, saying that the application deployed successfully. Then the developers will connect to this web application and they will test whether their tasks are working properly or not. So that way everything continues. But assume if the server is here, you have only one server. Assume we have some 100 servers or 1000 servers. Then Jenkins cannot handle to install all the softwares on 100 or 1000 servers. So Jenkins will not do a dedicated work. It only job is, it's a mediator tool. It will communicate, it will delegate tasks to other tools. It won't do one particular task. So for that reason we have another tool called Ansible. So before we understand what Ansible tool is, we try to understand a scenario. For example, you want to install Java on 300 machines. So when there is no DevOps tools available at the time, some 20 years back, then what we have to do? manually, administrators has to do log into 100 all the 300 machines and log in the servers and check whether Java installed or not. So if Java is already installed, then they have to uninstall it, because the Java which is installed on it maybe an older version, right? Maybe an older version. That is the reason they have to uninstall it and they have to install the latest version. So they have to do that. So they have to perform this activity on all the 300 machines. So get the software from shared folders, install the software, reboot the server, right? All the manual process of deployment in historical way takes lot of time to complete deployment on all servers. So if you do this way, they used to do this way actually long time back when there are the desktop applications. They used to do that way because there is no urgency, right? But now there is urgency, right? So in a sprint, in one sprint we have to complete everything. That is the reason we have we are DevOps, we in DevOps tools having another tool called Ansible. Ansible is called as a configuration management tool. Ansible tool do its job is that its main job is that deploying softwares into any number of servers. The main job is deploying any software. It can connect to any software. It will check whether already Java is there or not. If Java already there, it will uninstall it and it will install it in fraction of seconds. So in those 300 machines, it will do the job in 3 minutes. Max 4 minutes, it will install Java version, correct version in all those 300 machines within 3 minutes. So you should understand that Ansible is a tool. Its job is installing the software. That's all, nothing more than that. Right. So now introducing DevOps process, we include a tool called Ansible into the deployment process, which run playbooks of commands. Here playbooks nothing but like paintbrush. We have JPG file, right? So you say JPG file. If you talk to anybody, if you say JPG file, he will understand. So if anybody knows Ansible, if we talk with him say playbook, then he will understand. What is playbook? Again, it is a simple file, a file which contains some commands. So in Ansible terminology, we use a new word called playbook. Don't confuse, it's a simple a file, right? Here on the right side, I'm showing the playbook and some commands I'm showing inside that file. Connect all and yum name equal to Java 1.7, something we mentioned over here. Don't go in depth actually. So finally, what it's doing is that when you execute this playbook, this Ansible tool understands that okay, I have to connect all the 300 machines, the 300 machines which we are talking in the previous screen. It understands that I have to connect all the 300 machines and I have to install Java version 7 on all these machines. So it will do it immediately. But Ansible should know, right, to which server, which server it has to connect, right? Those details we will give in another file called inventory file. Inventory file is a file there we maintain some sections like dev section, UAT section, production section. So these names are not mandatory to give this way. You can give any name. Dev, you can give development also, you can give UAT environment also, you can give without space in that file. And under each section you have to give, suppose in the previous section we are saying 100 machines, right? So 100 each machine have some unique address. Like every house will have an address, so every server will have an address. It's called IP address. So every server will have internet protocol address. So every server will have a unique address. It is called IP address. So all those 100 machines which are under dev section, we mention under dev section. Similarly for UAT, all the 100 machines we have to mention. So all IP address we have to mention under this. So when you say in place of all, if you say only dev, then Ansible will connect to only to dev and dev section, and under the dev section 100 IP address are there. Then Ansible connect to all those IP using that IP address, it connect to all those servers and it will install the Java. But instead of you say all, then Ansible blindly connects to all the servers, 300 servers, and it will install Java within fraction of seconds, right? As shown above, Ansible deploys hundreds or thousands of servers at a time. So the time here is reduced to just to 4 to 5 minutes instead of hours. So now what happens now? Jenkins, instead of doing deployment job, Jenkins delegates that job to Ansible tool now. So because Ansible tool is made for that. So it will do software deployments. For that reason, you can connect Ansible tool with Jenkins. So how to connect those stuff we will see later on. But you should understand that we can connect to any tool to Jenkins using a plugin. What is plugin? Using a software. So how to do that we'll understand. So now Jenkins delegate that work to Ansible tool now. Then Ansible now able to install that software into the target machine. The target servers can be 1 or 100 or 1000. Ansible will install that software into that. Next comes Terraform. So Terraform is a infrastructure management tool. So it will create only infrastructure. It will not install any software. It will create servers. It will create networking infrastructure, everything whatever you want it will create for you on the cloud. On the cloud you can use it on the on premises as well, but these tools work efficiently on the cloud. So Terraform creates only the instances, only the infrastructure. So why we require this? So why we require this? Because so as a DevOps engineers in real time we will be serving to multiple projects. We will be working with multiple projects. So multiple projects will take our service. So one team may ask us to prepare some 40 servers, another team may come to us and they say prepare 50 servers, another will come to us and say prepare some 35 servers. So and again they will modify here and there after some period of time, gradually after 3 4 months, as the project grows on they change the requirements. Not only servers, they will request us to create some other infrastructure as well on the cloud. So to manage all those things manually on the cloud, even the cloud can create in minute, within seconds or minutes, even do that job. But again, as manually if you want to handle everything from our side, then it's very difficult to handle, very difficult to handle. So even you say if take Ansible now in this example, so Ansible in the script it will maintain what softwares are installed. It will have everything documented in the playbook in this in this file. So if a new joinee comes here and he wants to understand what all these servers having, which software they're having, he can simply go to the playbook and by seeing the playbook he can see all the software. Here I'm showing only Java, but in real time we don't have only one Java. It will contain a lot of softwares mentioned in this file. So the new person will immediately understand, okay, these are all the file softwares installed in this in those machines. So automatically this file serves as a documentation as well. So a newcomer easily understands what software is installed in these servers. So now it doing two jobs, right? Documentation part also it doing, right? Similar way, Terraform also. In Terraform also we have to maintain some files. So this file extensions have .tf. So Ansible playbooks have extension as YAML. So here, what is YAML files? Those I will explain you from scratch in coming classes. But here Terraform maintains extension as TF. Here we are saying sample.tf, but for every project we can give a separate name. For example, project A we can say A.tf. For project B we can say B.tf. So in A.tf we will mention all the infrastructure details, like how many servers they want, what infrastructure they want to create. Everything you will mention in the script in the TF file. Then Terraform when you run the Terraform tool, the tool will connect to this file, and accordingly whatever you have mentioned in this tool, we will also mention to which cloud we have to connect. You can also mention whether to connect to cloud, Amazon cloud or Azure cloud or Microsoft cloud, sorry, or Google cloud. Whatever cloud you want to connect, you can mention over here. Then Terraform will connect to any cloud. It's a cloud independent, actually it can connect to any cloud. Just you have to mention which cloud you want to connect into it, and after connecting to it, what infrastructure you want to create in that cloud. Those things you have to mention in this file. Then Terraform will connect to it and it will uh, create the instance service infrastructure required here. Once suppose this is called Amazon EC2. Amazon EC2 nothing but it's a server, it's a server. So this there are two servers created now by Terraform. And now Terraform immediately do what? It will also it will auto create a file called terraform.tf state. State means it will maintain the state information, like no, till now what job it has done, what job it has, latest job what is that is completed. So latest job it completed is it created two servers, and what are their IP addresses. Every detail will mention in this tf state file. So and after that Ansible automatically starts running, and Ansible to do what? It will check what software to be installed, which are mentioned in the playbook. It will study the playbook and it will go through each line and everything, and it understand that what software to be installed. That is fine, but into which server it has to install, that information it will fetch from the terraform.tf state file. Because in this file Terraform tool already written the details, like what is the IP address of this server and what is the IP address of this server. Those details mentioned in this file. Then Ansible will go to the server and it will fetch the IP address of those servers, and it will connect to the cloud, and it will install the softwares mentioned in the playbook. This way everything will be automated, and within fraction of minutes all job will be done. If you have any questions till now, please let me know, so that I will continue with another topic called Docker containerization. Okay, in the case, okay, let me continue then. So Docker containerization, what is Docker containerization? Before understanding that, let's try to understand what is virtual machine. So long back, I'm going to say some 20 years back at the time, uh, Infosys like companies, they have their own data centers. The data center is nothing but a building. In that building, only servers will be running in that. So in that at the time, suppose at the time you want to deploy one application, then that for that one application, it requires one complete server. So in that one server, we cannot install another application. Only one application used to run in that one server. So that one server, one application will not able to use the complete infrastructure. That means the complete hard disk and the complete RAM, the complete CPU. That one application will not able to use it because only one application is running. So because of that, at the time lot of switches used to happen. So if there are 10 applications, then at the time 10 servers, individual servers has to be bought, and application has to be installed in them. So these 10 applications will not use complete what do you call the infrastructure of that physical machine. So at the time lot of wastage was used to happen. So later on, slowly a new concept came called virtual machine. So what is virtual machine? So before you understand what is virtual machine, we need to understand a software called hypervisor. Hypervisor is a software. So on one physical machine, once we have CPU and RAM and hard disk, on top of it anyway we install OS, and on top of it we install a software called hypervisor software. This comes from various companies like what do you call Citrix company have their own hypervisor software. So so many are there actually. What do you call I'm not recollecting those things now. So many softwares are there. So what they do is the main job of those tools are they logically partition the physical server. They logically partition the physical server. So logically, that means this one partition, this another partition, this another partition. So this hypervisor do what? It virtualizes the infrastructure. It virtualizes the infrastructure such that each partition will have its own OS. It will have its own OS, and each partition will have its own application running in that. So if you install Java, this Java assumes that it is working independently on a physical machine. It assumes like that because it having its own OS. Similarly, another partition will contain its own OS. On the top of it, another application will be running, and it also assumes that it is running on a independent physical machine. So these applications, when they required hardware, they want to need some hardware, then hypervisor will fetch it from the physical machine. So hypervisor virtualizes the infrastructure that such a way that they will never know that they are not getting it from the logical they are not getting from the logical partition. Actually they're getting it from the physical machine. So they never come to know that. So everything the hypervisor will maintain whatever hardware requirement they are having, hypervisor will take care such requirements. So these each partition, logical partition, we call as a virtual machine. We call it as a virtual machine. We won't call it as a virtual logical partition. We name it as a virtual machine. So a lot of companies still today, in future also, they continue using it. Because what happens is that because of this now, because 10 applications are running in it, for example, assume, then these 10 applications can efficiently use the infrastructure. They can efficiently use the infrastructure, and the wastage will be very minimal because every application will be using the infrastructure. The only problem here exists is that every virtual machine have a guest OS. So for time being, assume these all guest OS is Windows OS. And as you know, Windows OS consumes around 18 GB initially. Once updates are done, then it goes to 25 GB. So here we have 10 partitions, for example, and 10 partitions, 10 applications are running fine. That is fine. But the OS itself taking 10 into 25 GB, 250 GB is going to OS, right? But in reality, the application, how much space it is taking? It may be taking 800 MB, maybe 1 GB max, maybe, right? So all 10 applications may take maximum 10 to 15 GB, right? Maximum. So, but OS taking 250 GB. So now some companies understood the situation. So one of the company called Docker company did what? They understood the situation, and what they tried is that, what if we avoid the complete OS here? What if we virtualize, instead of virtualizing the infrastructure, what if we virtualize the OS itself? What if we virtualize the OS itself? So by that, they tried and tested, and finally they released their product into the market. It's called Docker, and in place of hypervisor, we got a tool called a software called Docker Engine. So this Docker Engine do what? It will virtualize the OS itself. So, and here applications have their own partitions. Now they will contain their own partitions, they're running in it, but they don't have their separate OS for them. So whenever they want to communicate with the OS, then Docker Engine will serve the purpose by providing whatever requirements from the OS. It will serve it. So Docker Engine stays in between to application and the OS, and Docker Engine will virtualize the OS, and whatever requirements they have, the Docker Engine will take care. It will communicate with OS whenever they want anything with OS. For example, they want to store some data into that hard disk. So such request has to go to from OS, right? OS then communicates with the infrastructure, and OS will directs them to create some space so that some data will be stored in the in the hard disk. So that information will pass it through Docker Engine. So it want to store some data, okay, Docker Engine will take that information and it will communicate with OS saying that prepare some data, we want to store some data. So in the hard disk, then OS will take care and it will communicate with the infrastructure. This way, here we have avoided all the guest OS part. This layer completely removed now. And now we say, here we are saying virtual machine. Each partition, logical partition, we are saying virtual machine. But now in place of virtual machine, this partition we say container. See, we won't say virtual machine now. We will say container. When you are working on Docker, we will say container. When you are not working on Docker, when you are working on what do you call virtual on the cloud, for example, on the cloud, everything is virtual machine concept. If you take Amazon, Amazon mostly gives you a part, a logical part only. It will never gives you a physical part. But if you want separately physical part, you can always avail it, no problem. Amazon will give you a complete physical machine without any partition, but they charge more. That we will discuss a little bit later. So now Docker, when you are working on Docker, then we should say, not say virtual machine, we should say container. So Docker, that's why it is called as containerization tool. Then what advantages we have got here? The advantage we got here is that now, because we are saving a lot of space here, lot of memory space here, because we have completely avoided OS here. So for that reason, previously we are able to install only 10 applications. Now we can easily install 40 to 50 applications on the same physical machine. Now we are able to install 40 to 50 web applications on the containers, right? Because of that, the company gains a lot, right? The company gains a lot, right? So they no need to purchase multiple servers. On a single server, they can deploy multiple applications. Yes or no? So that way, in real time, there won't be one machine, one physical machine, and running 40 applications on that. In real time, there will be hundreds of containers will be running on 15-20 physical machines. So when 15-20 physical machines you are using, then easily you will be having more than 500-600 containers running, and in each container the application is running. When 500-600 containers are running, then as a DevOps engineer, we got another problem now. So how to manage these containers? Suppose this application A crashed in this container, but we have around 500-600 containers running, and each container there are different applications are running, some duplicate applications also running. See, assume not assuming, in real time, one application, only one application will not be running in one container. The same application will be running on around 20 containers or 30 containers. Because why so many containers? Because if one container crashes, then another container will take care, because it having the same application running in it. So that is the reason we have duplicate containers which having same application running such way, that way. So if there are 10 applications, then 10 into 20 means 200 applications, 200 containers are running, right? So if any of the container is crashed, then the container has to be replaced immediately. If you don't replace it again, the containers count can come down, and finally all the containers may crash. That is the reason. So that as a DevOps engineer, we cannot manually watch all those 500-600 containers manually. We cannot. So that is the reason a new tool arrived, which manages all these containers. That tool is called Kubernetes. So before go to Kubernetes, I like to give a small differences between these two things: virtual machines and containers. It will important. Containers, virtual machines are very heavy weight, and containers are lightweight. And virtual machines have light performance. These have native performance. And each virtual machine runs in its own OS. All containers share the host OS. Hardware level virtualization, but in container in Docker we have OS virtualization, complete OS virtualization. Startup time in minutes, because in virtual machine we have guest OS, right? So guest OS should start first, and then after that application has to start. But here we don't have OS, right? That's the reason application only have to start. That is the reason startup time in milliseconds, whereas here it takes minutes to start the application. Allocates required memory, here requires less memory. Fully isolated and hence more secure. Here process level isolation possibly less secure. Okay, so as we're talking about 50, 500, 600 Docker containers, then to manage them, Kubernetes is an orchestration tool. The main job of Kubernetes is that its main job is maintaining all these containers. Here in this picture we have pods. I'm not talking about pod now. So in short, pod contains containers belongs to same project. But anyway, I will not get into that depth. But at least you try to understand the purpose of Kubernetes. The purpose of Kubernetes is that if any of the container crashes, then Kubernetes immediately detects it, and immediately it will communicate. So see here worker node 1 is there, worker node 2 is there. So it is nothing but one physical machine. This is another physical machine. In this example, I have taken only two physical machines. In reality, we will have multiple physical machines. In each physical machine, there will be hundreds of containers running. So in this container, suppose this container crashed, then Kubernetes immediately communicates in this physical machine. There will be a Docker engine will be running. Then Kubernetes will instruct to Docker engine saying that this container has been crashed. Then Docker engine will immediately creates one more container, and in this container it will also install the application, and it starts the container. So this way, Kubernetes is able to watch all the containers at a time. So as a DevOps engineer, our life becomes easier as well. So that is the reason in industry, most of the companies nowadays going to Docker and Kubernetes. So in this course, we are learning Docker and Kubernetes in very depth. So at the time, you should give a lot of uh, time to this. I may take some extra class as well for this Kubernetes and Docker. So mostly for only on Docker and Kubernetes, we have a lot of jobs only on Docker and Kubernetes. Even though we are learning Ansible, Jenkins, and various tool Terraform, but only Kubernetes and Docker, we have a lot of jobs in the industry. So I suggest that you prepare for Docker and Kubernetes in depth while I'm teaching it. And that is fine. That is fine. Now another problem there, that when these hundreds of containers are running and these applications are crashing, if one of the applications is crashing, Kubernetes immediately informs to take care and informs to Docker engine to create a new container. That is fine. Up to there it's fine. But why the container has crashed? Why that container has crashed, and what is the reason? If it is crashing again and again, no problem, container Kubernetes will create it again and again, no problem. But thing is, why it is behaving like that? So then we have to monitor those containers, and if we want to monitor it manually as a DevOps engineer, it will be very difficult, because we have a lot of containers, like 400 500 containers are there. Because this application may be consuming more RAM, more CPU, more processor. Because of that, the application may be crashing. So but as a manually we cannot watch it, right? So that is the reason we have a tool called monitoring tool called Prometheus is a tool. Its job is that it will monitor us whether how much hard infrastructure that application is using, how much processor it is using, how much RAM it is using. Those things it will watch, and it will log into the in a log file in a text format. So Prometheus will log all those incidents, and it will inform in the log file. So after that, the administrators will check the log file, and it will understand that okay, so and so application running in the so and so container consuming more processor, consuming more RAM. So that it will they will come to understand, and they will inform to the respected team, development team, saying that this application misbehaving. So the application team will fix it, and they will redeploy. But problem with Prometheus is that it will store in a text format. So to get more Docker the DevOps engineers will not feel comfortable by seeing the text, right? If the text having a lot of lines, then it is not comfortable, right? So to find the main issue, some issues, it's difficult, right? So that is the reason we have another tool called Grafana. Grafana is a visualization tool. It's a visualization tool. It do what? It shows the same data, log data, in a graphical format, in a charts and bar charts format, so that as a DevOps engineer we can easily see, we can easily detect the problem, and it is very easy to, instead of going line by line, this charts helps a lot actually. That is the reason we learn another tool called Grafana. So finally, we have the complete flow. Finally we have the complete flow, like from the beginning, from developers to Jenkins, and once it builds, and testing will happen automatically, and then will be deployed into the servers by Ansible, and the infrastructure is prepared by Terraform. And by now you know why is Docker, why is Kubernetes, right? And you know what is this tools are, monitoring tools are. By now you got some introduction of them. So I'm done with this today. I want to know if you have any queries now. Let me know if you have any queries till now, so that I can clarify them. So bear with me for a few days. Because some new journeys are coming up, just I want to take them with us. Once it starts, no stop there. So because I am taking on weekends as well, so that I can cover more topics. So that is the reason. Just bear with me for a few days. Later on, we will rush like anything. Of course, make you comfortable. With comfortably, we will go slowly. Don't worry about it. I'm rushed in the sense, every topic I make you understand. I will take your feedback only. I will move. If your feedback is not good, then I will stop there. I will know your concerns, why you are not understanding. I will take your feedback only. After that, I will continue. So honestly, I need your feedback as well, after at least for few days, so that no, if I'm very speed, or something you are not able to understand, just honestly let me know in the class itself. No problem at all. So that it's maybe other problem for others as well. That is the reason. Somebody with no name waiting for, may I get your name please? Please, waiting for, I'm showing seeing waiting for. Can I get your name please? I don't see your name here. Sorry, on that day I said UHA, but later I got it's Hua. Nice name, yeah. How are you doing, Hua? Any doubts in this session, Hua? On the day you may not join this session, maybe you missed it. Any questions you have, Hua, on the day, on this demo today?
No, I don't have any questions, but literally that the class is going good. Moving forward, we need to see.
Okay. Uh, uh, okay. Uh, can you speak it out, please? I missed. I'm sorry. Speak it out one more time, please. Try to understand.
What?
I'm sorry.
Yeah. Mm,
No questions, right? Okay. Okay.
yeah.
Okay. Nice. Nice. Wow, nice. So, waiting for. May I know your name, please? Or you can ask if you have any questions. And every day I will share the recordings. Every day I will share the recordings. The same day after the session is complete, I will share the same day, right? So if you have any questions, let me know. I will wait for 1 minute for your response.
Yes, Madan, I just want to actually, I don't understand that the difference between the virtual machine and the Docker. Can you please repeat it once?
Okay, I got it. So, Revanti and others, I will take a special class for this again. Um at what time you are comfortable? Today evening, 7 p.m. is comfortable for you? Who are not understanding? Today evening, 7 p.m. At 7 p.m. to 8 p.m. I will take one more session only for you people, so that if you do not understood anything now, I will take some. I will spend some time in the evening if you want.
Yes, yes, it is fine for me.
It is fine for you. Yeah, so
Yes.
others as well, please, if you are not comfortable, did not understood, you can join today the same link, evening 7 p.m. I will join at 7 p.m. and ask your questions. I will repeat the topics whatever you have. So I will do these things for some time. For some time I will do this till you are comfortable. Okay, Revanti, please note it down. Today, tomorrow, today we will connecting at 7 p.m. evening.
Okay, sure, Madan. Thank you.
Thank you, Revanti. And people who are non-IT also, you can join if you want today at 7 p.m. evening. Same link you can use. For few sessions, I will take like that until you are comfortable. I will give another 15 seconds, 20 seconds, no problem. If you have any questions, please let me know. Okay then, we will meet tomorrow same time at 9 a.m. And people who having any questions can join today meeting evening 7 p.m. We'll connect and discuss. Thank you all. Have a good day. Take care.
Thanks, Madan.
Thank you.
Thank you, Madan.